In this video, I'm going to discuss about the effect of smart city initiatives on environmental sustainability in cities based off of my literature review. Before I start, I will briefly go over the definition of the city. City is a permanent and densely settled place with administratively defined boundaries, whose members work primarily on non-agricultural tasks. It also contains extensive systems for housing, transportation, sanitation, utilities, land use, and communication. According to the report by the World Bank, urban areas will take up to 70% of global population by 2050, as well as to be a medium for 80% of global GDP. This state of city clearly denotes that its failure to fulfill the given role will eventually lead to devastating consequences within human lives. Yet, global cities are still vulnerable from the surging climate impacts, such as accelerating sea level rising, frequent extreme weather events, and massive loss of natural resources. Therefore, it is crucial for cities to improve environmental sustainability and resilience for enhanced security in the future. The concept of smart city has been discussed as one of the promising tools to achieve this goal in terms of its intelligent use of digital information in a wide array of areas from energy use, mobility, to even urban governance. The definition of smart city is divided into two big concepts along the current discourse. One of them is a smart city as a technology-intensive city with sensors everywhere and highly efficient public services using real-time collected information by thousands of interconnected devices. For example of this, it is like trash cans have sensors that indicate when they are full, and trash collectors follow a specific route based on this information. Or all buildings are intelligent with smart meters and energy-saving systems, and transport is painless. Another aspect of smart city is as a city that cultivates a better relationship between citizens and governments leveraged by available technology. This branch is requiring the feedback from citizens to help improve service delivery and creating mechanisms to gather this information. And citizens are more active in managing their neighborhood. And for example, open government data is used by civil society to create smart city applications. It can be used for reporting a full trash can, and trash collectors can accommodate their routes based on this information. Now, how can we identify or have indicators for environmental sustainability in cities? I use the Sustainability Assessment by Fuzzy Evaluation model. According to this model, the indicators for urban environmental sustainability can be identified as three large categories: water quality, soil quality and land resiliency, and air quality. But in this case, I picked four among them as the indicator, which is energy consumption, like how much energy is being used within the cities, and renewable energy, what ratio does renewable energy is consisted in the generated electricity grid, and greenhouse gas emissions, how much greenhouse gases are being emitted within the cities, and public transport, how well does public transport is available for the citizens. In this regard, numerous scholars acknowledge the smart cities as effective tool to promote respective aspects of the environmental sustainability through improving transportation in cities in a ways of advanced emissions monitoring device and data collection process and more efficient public transport systems, and also by reducing energy consumptions as well as energy mix portfolios in cities and enhancing resource management practices and related infrastructure with technology in sustainable manner. In order to support my point, I conducted a case study on the Kitakyushu Smart Community Project, which is an outstanding implementation case along with collaborative partnership among private and public sectors to promote environmental sustainability in cities. To briefly introducing about Kitakyushu, the area of the region is 485 square kilometers and the population of it has 975,000 people. And this region is a foundation of industrialization of Japan. And since it has numerous factories within the area, always heavy pollution on air and water quality can be easily observed. The background of this project is that the project is implemented by Kitakyushu Smart Community Council, which is consisted of Kitakyushu City and 67 companies and organizations. The management members are Kitakyushu City Government, Fuji Electric, Nippon Steel and Sumitomo Metal Corporation, and IBM Japanese branch. The area of implementation of this project is the Higashida district within Yahata Higashi ward, which accounts for approximately 1.2 square kilometers. The period of implementation started from 2010 and ended in 2014. And the scale accounts for 38 projects with the fund of 16.3 billion Japanese yen. The initial proposal for this project was established in 2009 by the partnership consisted of IBM Japan, Fuji Denki Electric Systems, Kitakyushu Municipal, and Nippon Steel under the leadership of Nippon Steel, who is the main figure of the governing coalition of the local business leaders. The project began in 2010 when it obtained the approval from Japanese central government intervention policy initiative and supported local big and small low carbon environmental projects and green technology innovation projects. Its goal aimed for promoting alternative energy systems and new microgrid energy network associated with smart meters as well as reduce 50% of 2009 based greenhouse gas emissions by 2014. As a result of this project, despite the absence of dominant regional power company, the project diversified the upstream energy dynamic by assisted Nippon Steel to provide hydrogen gas into the government-certified Higashida community, and Fuji Denki System also contribute to its diversification through providing mega solar systems. Also, Toyota Motor Kyushu produced two prototype hydrogen gas-fueled vehicles for Kitakyushu municipal government when the project completed to build hydrogen fuel station. 225 of local households use smart meters and 50 businesses implemented building energy management system. And this picture is the wholesome collection of the products through this project. And as you can find in this picture, the project successfully restored the degraded air and water quality in these days. While smart city initiatives numerous positive environmental effects on cities, there are some raised concerns regarding its obscure negative effects on urban environment sustainability. Due to its nature of high dependency on the ICT applications, smart city initiatives will increase the energy consumption and carbon footprints by running excessive amount of ICT equipment in various circumstances. Also, the increased demand of ICT equipment causes additional toxic chemical uses for its manufacturing, as well as additional e-waste generation from disposal of end-use equipment. In addition, due to the nature of fast-paced development of new technology and appliances, the obsolescence of old ICT application will result shortened life cycle of the products. The current discourse revolving around the smart city initiatives and its impact on urban environmental sustainability is still divided and complicated. Utilizing advanced technology and solving current environmental issues that cities facing ironically also produce another environmental issues. However, despite the contradictory aspects of smart city initiatives, it is expected to have possibility of balancing out the negative effects with improved aspects of positive traits of the smart city initiatives, such as exceeding energy saving over its consumption through enhanced energy efficiency and stewardship, as well as its renewable energy mix, and also improved resource management by replacing waste generating materials to more sustainable sources. And it is key to further explore of what measures can effectively fill up the gaps of these contradictory traits of utilizing smart city concept on achieving environmental sustainability. Thank you for watching.